All right, this is Advanced Math Unit 4 review, or 4A, for the first part of Chapter 4. Looking at number 3, so the first question says, sketch the angle in standard position, determine the quadrant in which the angle lies, list one positive and one negative coterminal angle. Okay, so the question is 4/3 pi, and I got a couple of different ways to do this. But if you're having problems finding out where they fit into the quadrants, you can do one thing is you can go ahead and turn it into a decimal to kind of give you a little bit of a understanding. So this is 1.3 pi. Okay, so if you remember, this is 2 pi, or 360. This is pi over 2, or half pi, which is 0.5 pi. This is 1 pi. This is 1.5 pi, or 3 over 2 pi. Right? So we can tell it's right here. It's in quadrant 3. Okay, and this is one of the ones that we should recognize, but I'm kind of treating it like I don't, because it has a denominator of 3, so I know it kind of fits in and has a pretty nice reference angle. But so I know it's in quadrant 3 by kind of looking at it that way, and it's like 60, you know. So it's right there in the standard position. Okay, now standard position means I start at the positive x-axis and I go all the way around, and that is the angle 4 pi, or 4/3 pi. Okay, and it's in quadrant 3. Okay, it's in quadrant 3. Now, if I want to determine some coterminal angle, so I got two ways to get to or really an endless amount of ways, but two of the most popular ways is I add 2 pi and go all the way around and end back in the same spot, or I go with a negative angle going this way. Okay, so let's go ahead and add a 2 pi. That would be one additional revolution. Okay, so 4/3 pi plus, I need to add 2 pi to it. So I need to get a common denominator, so that's going to be 6 pi over 3. Okay, so that's 10 pi over 3. Okay, so that's one positive coterminal, meaning ends in the same spot. Now I'm going to do the negative one, so I'll do 2 pi minus 4/3 pi, and I got to do the same thing, get myself a common denominator. Okay, and I'm looking at 2 pi over 3. Okay, 2 pi over 3. So a positive 2 pi, now a positive 2 pi over 3 is over here, right? So I need this thing to be negative. So if I go positive 2 pi will put me over here in quadrant 2, but since I'm going the other way, it's going to put me over here in quadrant 3. So negative 2 pi over 3 and positive 10 pi over 3. Okay. Next question, number 9, says, sketch in the standard position, determine the quadrant which angle lies, list one positive and negative. So they want the same thing, but they're doing it with degrees versus radian measure. Okay, so kind of giving myself a picture here, and it's negative 135. Okay, so just if I want a positive 35 is the same as 90 plus 45. So positive, okay, 135 would be right there. That would be positive 135, but I want it's negative, so it's really down here. Okay, it's really down here. Okay, and I'm going to repeat the process. I'm just going to do it with degrees. Okay, so I'm traveling this way. So if I want to do one additional revolution, okay, one additional revolution and end up on the same spot, go in the same direction, I'm going to subtract 360. Okay, I'm going to subtract 360, and when I do that, I get 360 plus 135, and that's negative 495 degrees. That would be going all the way around and end up in the same spot. If I went the other way, right, as in a positive one, that would be, you know, So now I would do 360 minus 135, okay? And 360 minus 135 is 225. Okay. So I could go, this is positive 225. It's negative 135. If I keep going around one more time, it's negative 495. Next question, number 29. 29 says, if possible, find the complement and the supplement of each angle. So 29, so the answer is 3 pi over 10. Okay, so remember, a complement is when two angles add up to 90, and a supplement is when they add up to 180. Okay, so just kind of, if I'm having problems determining how big this is, and I need to kind of turn it in degrees or have some, just kind of get a feel for it. The reason I want to make sure that it's less than 90 degrees. If not, it doesn't have a complement, okay? So 2 pi, 0.5 pi, 1 pi, 1.5 pi. So just kind of figure out what quadrant it's in. And 3 divided by 10 is 0.3. Okay, so it's right here. Okay, it's right here. So I know, okay, it is in quadrant 1, so it's going to have a complement as well as a supplement. Okay, so just to find them, so first I'll go ahead and subtract by 90 to find my complement. Common denominator of 10, so I multiply this by 5 over 5. Right? Oh, sorry, that's 10. Okay. And I should have just put these the other way around. Sorry, so it should really be 5 pi. You can just ignore the negative sign. And that gives me 2 pi over 10, right? If you can see that, that'll get me to half a pi. 3 plus a 2 is 5. 5 over 10 is a half, okay? So there is my complement, okay? And for my supplement, I'm going to subtract from 180, or in other words, pi, because I'm doing this in radians. So this would be 10 pi over 10 pi minus 3 pi over 10 pi, and that's 7 pi over 10, or 7/10 pi. Okay. Moving on here. Number 37. Number 37 says, find the length of the arc on a circle with a radius of 20 meters intercepted by a central arc of 138 degrees.